Hi, I'm Cheryl Koenig, and I'm doing my video on, or my lab one, on baking soda and vinegar rocket. My ingredients are a bottle with some duct tape and some pencils to hold it upright, a cork to put on the bottle, some baking soda, and some vinegar. What I'm first going to do is put the vinegar inside the bottle about to here. And then I rolled up baking soda inside of this toilet paper roll so that when it goes in, the toilet paper kind of disintegrates and the baking soda goes in. And then I'll shake it up and then we'll see what happens. Ready for this?
Yep.
Okay. Round, what is it? Really isn't safe. I did this experiment 4 times. The first time it went up, it went up and then it hit the ground. It took 3 seconds to do that. The second time it went 3.3 seconds. The third time went 3.5 and the last time went 2.5. I think the last one probably went a little bit less because I didn't put as much baking soda in there. So there are my data and results. Newton's first law states that an object at rest will remain at rest unless acted upon by an unbalanced force. An object in motion continues to stay in motion at the same speed and in the same direction unless acted by an unbalanced force. My experiment showed this, Newton's law of motion. When it was upside down like this, the baking soda and vinegar were put inside and it was upside down like this. And then when the chemical reaction occurred, there was an unbalanced force and there was more of a force down here, so it made the rocket shoot up. And it kept going in that motion until it switched directions because of another unbalanced force right here, which was pulling it down, which was gravity. The second law of Newton states that acceleration is produced when a force acts on a mass. The greater the mass, the greater the force needed to accelerate the object. The force for my rocket was the chemical reaction that made the cork fall off and made an unbalanced force in the bottom, which made it accelerate upwards. And then the unbalanced force of the gravity pulling the rocket downward made it accelerate down. Newton's third law of motion states that for every action, there is an equal and opposite reaction. In my experiment, this was shown when the rocket was shot up by the force because of the chemical reaction and then came back down because of gravity. And in that arc that you could see to the left, the 2 separate points are equal, and they're going all the way down at the same points, they're equal going down. The challenge of this experiment was to get this rocket off of the ground using an unbalanced force. This experiment experienced all of Newton's law of motion, the first, second, and third. And the results of the experiment showed pretty consistent throughout all 4 launches. I would like to thank Amber Wibanga and Kenny Swenson for helping me videotape these videos.